Good evening, everyone. Okay, today we'll be looking at differential equations using the Bernoulli's theorem. So, let's say Bernoulli's equation rather. So that's what we are going to be looking at today. All right. If you remember the last time we had this tutorial, we talked about the linear equation. Okay, whereby you have the linear equation, whereby you have that dy dx is equals dy dx plus py equals to q. Okay, so in some of the differential equation, it's not all differential equation that are like this, that are in this form. So there are some of the differential equation that will look like this, that is dy dx plus py, which is equals to qy raised to the power of n. So there are some of the equation that looks like this. If you have an equation that is in this form, this particular one, the approach you give to it, the approach you use to solve it is different from this one. Okay, so if you have something like this, the approach is to use Bernoulli's equation. That is what you are going to use. All right, let's see how it works. Now, if you have your dy dx to be plus y, which is equals to qy raised to the power of n. So in order for you to, now the aim is to make it look like linear, like the aim is for us to make this equation to look like this. Okay, that's the aim, to make it look like this. Okay, so how do we do? The first thing we are going to do is that we'll divide by y raised to the power of n. That's the first thing we'll do. So let's do that. Divide by y raised to the power of n, and here also y raised to the power of n, and here also y raised to the power of n. So which means that we'll have that 1 over y raised to the power of n dy dx plus 1 over y raised to the power of n py, which is equals to q. Okay, then which will give us y raised to the power of minus n dy dx plus, now this here is going to be y over y raised to the power of n p, which is equals to q. Then you can have it as y raised to the power of minus 1 dy dx, then plus this is going to give you y raised to the power of 1 minus n, y raised to the power of 1 minus n p, which is equals to q. Now this form now is looking like that of the linear equation that we have here, which is this one here. Okay. Okay, so the next thing is let's make it more simpler. So let's say let this one be equals to, let's say, z. So you can say that let z be equals to y raised to the power of 1 minus n. Okay. Now, if we say that, then let's differentiate. So we differentiate with respect to x. So we are going to have that dz dx is equals to, we differentiate this one, which is going to be 1 minus n, y raised to the power of 1 minus n plus 1 dy dx, which is going to be 1 minus n, y raised to the power of minus n dy dx. Okay, so we have that dz dx is equals to, that is 1 minus n raised to the power of n minus 1 dy dx. So let's call this one equation 2, and let's call this one equation 1. Okay, let's try and put equation 1 into equation 2. Or let's do this way. Let's try and multiply through by n minus 1, so that we can have something. So you can simply say multiply equation 1 by 1 minus n. So if you do so, you know equation 1 is given as y raised to the power of minus n dy ds plus y raised to the power of 1 minus n p, which is equals to q. If I'm not mistaken. Yes, we are correct. So let's multiply through by 1 minus n. We are going to have 1 minus n y raised to the power of minus n dy dx plus 1 minus n y raised to the power of minus 1 minus n p, which is equals to q, or q into also 1 minus n, because it's everywhere, multiplying everything. Now you notice that this one from that equation 2 is the same as what? dz over dx plus this is going to be 1 minus n y raised to the power of 1 minus n p, which is equal to q into 1 minus n. Okay, so this is the form. This is the form, and don't forget that from here, let's look at something here. Let's look at something from here. You notice that our z is equals to y raised to the power of, okay, y raised to the power. So we can say that dz dx is equals to this one. The whole of this one is what is z. So we can have it as plus, that is z into n minus 1 p, then which is equals to q into 1 minus n. All right, so let's do something. We call this the whole of this one, or rather the whole of this one, that is p into 1 minus n. We call it something. We can call it, let's say c, for example. Then we call this one q as q into 1 minus n. So therefore, we just say that. So the formula finally to look like this: dz dx plus cz, which is equals to what? Small letter q. So you notice that we have now broken it down to what? To this form, like the linear equation. All right, so let's solve some examples so that we understand the concept very well. Let's say that you are given the y dx plus 1 over x y, which is equals to x y squared. If you are given something like this, the first thing you notice is that this is not supposed to be here. This y squared is not supposed to be here, right? So we have to make it. You have to make it in the linear form to make it look like this. That's the y dx plus the py plus the q. You have to make it look like this. So first of all, I have to remove this y squared. So what do we do? We divide both sides by y squared. So the y dx divided by y squared divided by y squared, then plus 1 over x y divided by y squared, which is equals to x y squared divided by y squared. So this will remove this, and we have that 1 over y squared dy dx plus y over y squared 1 over x, which is equals to x. Okay, let's write here. Then we have that y raised to the power of minus 2 dy dx, then plus y raised to the power of minus 1, because by the time you do the indices of this, it's going to give you minus 1, then 1 over x, and which is equals to x. So at this point, you say let z be equals to y raised to the power of minus 1. Isn't it? Then when I say that the z dx will be equal to, that is minus 1 y raised to the power of minus 1 minus 1, then dy dx. So the z dx will give us minus y raised to the power of minus 2 dy dx. Okay, then we now have that. Okay, so from here, so this is our original equation. Where is the original equation? Okay, this is our original equation. This one is our original equation. Let's call it equation 1. So let's write it again. We have y minus 2 dy dx, y minus 2 dy dx, then plus y raised to the power of minus 1 over x, then which is equals to whatever, which is equals to x. Right, this is our equation 1. All right, so let's put this. Now we already know that this. Now you notice if you compare this one and this one, so you notice this is y raised to the power of minus 2 dy dx, but this is minus y raised to the power of minus 2. So you have to multiply everything by minus to make it look like this, so that you can insert it. So let's multiply by minus. It's going to be minus y raised to the power of minus 2 dy dx. Then this is going to be minus y raised to the power of minus 1 over x, which is equals to minus x. Okay, so after the transformation, you notice that this one is looking like this one. Yeah, right? So they are looking like each other. So which means that you are going to replace it by what? By the z dx. So let's replace it. To replace it, we have the z dx, then minus this one. Don't forget it. You already said it to be y. Then z rather, so it's going to be z multiplied by or z into 1 over x, right? Which is equals to minus x. So at this point now, you can say that your at this point you can say that p is equals to 1 over x and q is equals to minus x, right? Okay, yeah, that's what we say. Then here you now look for the integrating factor. So integrating factor, which is if, will now be integral of is e. It's going to be e integral of p dx, which is equal to e integral. What is p? P is 1 over x dx, and which is going to be e raised to the power of the x, and which is equals to x. Okay, then you have that. Now your formula will come in this form. So instead for a formula to be like the other one, that's for the linear equation. So instead of formula to be y multiplied by if, which is equals to integral of q multiplied by if multiplied by ex, right? So your formula is going to be, so this is not going to be your formula anymore. So the formula is going to be z multiplied by if, which is equals to integral of q multiplied by if dx. Okay, let's compute it. We have that z is what? Okay, let's leave z for now. Z multiplied by if is what? X, that's the integrating factor, which is equal to integral of q. Q is minus x. And the if is what? Is also x2, then dx, which will give us minus x squared dx. Okay, then you have z multiplied by x is equals to minus integral of x squared dx. So once you integrate, you're going to have minus x raised to the power of 3 over 3 plus c. Then z multiplied by x is equals to minus x raised to the power of 3 over 3 plus c. What do you do at this point? You now remember that from here, you already said that let z be equal to y raised to the power of minus 1. Don't forget. So you now put it back here. You now see that y raised to the power of minus 1 multiplied by x is equals to minus x cubed over 3 plus c. So which will give you 1 over y multiplied by x is equals to minus x raised to the power of 3 over 3 plus c, right? So which is going to be x over y, which is equal to minus x raised to the power of 3 over 3 plus c. Then this is your answer. I hope that is clear enough. Let's take one more example for clarity purpose. Okay, let's say that you have x square y minus x cubed into y dx, which is equal to y raised to the power of 4 cos x. Okay, first of all, you have to, this is not supposed to be here. So let's rearrange first. Let's rearrange. So if you rearrange, it's going to be minus x cubed dy dx, and then plus x squared y, which is equals to y raised to the power of 4 cos x. So these are supposed to be, isn't it? All right. Now, once you have, first of all, you have to remove this thing. It's not supposed to be here. So you divide both sides by minus x cubed. So let's divide this also by minus x cubed. Also this one by minus x cubed. So this will remove this. Then this is square to remove, so it will remain x here. Therefore, you have that dy dx minus what? 1 over x y, which is equals to minus y raised to the power of 4 cos x over x raised to the power of 3. Now, at this point, you have to eliminate this one from here too. So therefore, what do you do? You divide by y raised to the power of 4, y raised to the power of 4, and y raised to the power of 4. Therefore, this will give you 1 over y raised to the power of 4 dy dx. Then this is 4, so this is going to be minus 1 over x multiplied by y raised to the power of minus 3. If you use law of indices, you get minus 3, right? Then which is equals to so which is equals to this. You automatically remove it. Then you have minus cos x over x raised to the power of 3. Okay. Now this is going to give you y raised to the power of minus 4 dy dx, then minus 1 over x multiplied by y raised to the power of minus 3, which is equal to minus cos x over x raised to the power of 3, right? So at this point, you can say let z be equal to y raised to the power of minus 3, and the z dx will be equals to minus 3 y raised to the power of minus 3 minus 1, then dy dx, which should be minus 3 y raised to the power of minus 4 dy dx. Okay. Okay. Therefore, you notice that this and this have to be equal to insert this one in position of it. What do? You have to multiply by minus 3 so that it can look like this. So if this is equation 1 and this is equation 2. So you have to make equation 1, this particular one here, to look like this. So what do? You notice you just multiply by minus 3. So if you multiply by minus 3, you have what you are looking for. So you have minus 3 times y raised to the power of minus 4 dy dx. Then also multiply some by minus 3 is going to be plus 3 over x y raised to the power of minus 3, which is equals to, by minus 3, this is going to be 3 cos x over x raised to the power of 3. As easy as that. Then this one now, this is now looking like this one. So therefore, you can put this one in position of it. So let's do that. We are going to have that the whole of this is going to be the z dx plus 3 over x y raised to the power of minus 3, which is equals to 3 cos x over x cubed. Now, at this point, this one, don't forget, is what? Is your z. So it will now look like z dx plus 3 over x z, which is equals to 3 cos x over x raised to the power of 3, right? This is 3. All right, so at this point, we can find our integrating factor. First of all, p is equals to 3 over x, and q, well, now let's small that q is equals to 3 cos x over x raised to the power of 3. Therefore, integrating factor is equals to e raised to the power of p dx, which is equal to e integral. What is p? P is 3 over x dx, and which is equals to e raised to the power of 3 ln x. And therefore, integrating factor is equals to e raised to the power of ln x cubed. Then finally, you have the word x cubed. So this is the integrating factor. All right, then you now apply the formula. The formula is now z, not y again. Z multiplied by I f, which is equals to integral of q multiplied by the if dx. Okay, which should give you z multiplied by x raised to the power of 2, because that is your integrating factor, which is equals to q is 3 cos x over x cubed, then multiplied by the integrating factor, which is also x cubed, then dx. This will remove this. Then you have that z dot x raised to the power of 3 is equals to 3 integral cos x dx. Now, when you integrate cos x is sine x, so 3 sine x plus c. All right, then we are almost there. Then we now have that z multiplied by x cubed is equals to 3 sine x plus c. So what do we do at this point? Z is equals to y raised to the power of minus 3. Don't forget, multiply by x raised to the power of 3, which is equals to 3 sine x plus c. Then we can say 1 over y raised to the power of 3 multiplied by x raised to the power of 3, which is equals to 3 sine x plus c. Then, therefore, we now have that x raised to the power of 3 divided by y raised to the power of 3 is equals to 3 sine x plus c. So this is your answer. Okay, let's take the final example for today. Okay. If you have 2y minus 3 dy dx, which is equals to y raised to the power of 4 e raised to the power of 3x. Okay. First of all, let's rearrange it. So if we rearrange it, it's going to be minus 3 dy dx, then plus 2y, which is equals to y raised to the power of 4 e raised to the power of 3x. Now, let's divide both sides by minus 3. Minus 3. Minus 3. This, remove this. Then we are going to have y dx, then minus 2 over 3y, which is equals to minus y raised to the power of 4 b raised to the power of 3x over 3, right? But the next thing is to divide by y raised to the power of 4. So if you do that, divide by y raised to the power of 4, also divide by y raised to the power of 4, and also divide by y raised to the power of 4. So this remove this. Therefore, we are going to have 1 over y raised to the power of 4 y dx, then minus 2 over 3. This should be y raised to the power of minus 3, which is equals to minus e raised to the power of 3x over 3, right? At this point, we can say that y raised to the power of minus 4 dy dx equals, that's minus 2 over 3 y raised to the power of minus 3 is equals to e minus e raised to the power of 3x over 3. All right, at this one, we say let z be equals to y raised to the power of minus 3. And in so doing, we say the z dx will be equals to minus 3 y raised to the power of minus 3 minus 1 dy dx, which is equals to minus 3 y raised to the power of minus 4 dy dx. Now, let's call this equation 1 and let's call this equation 2. Right. Now, if you compare equation 1 and equation 2, the only difference is just the minus 3, like here. So we need to have minus 3 here as a coefficient of that y. So what do we do? Multiply. So it's going to be minus 3 y raised to the power of minus 4 dy dx. Then if you multiply something by 3, it's going to be minus, that's plus 2 times 3 over 3 y raised to the power of minus 3, which is going to be 3, which is 3e raised to the power of 3x over 3. This remove this, remove this, and we have minus 3 y raised to the power of minus 4 dy dx, and then plus y raised to the power of minus 3, oh 2, rather there's 2 here, 2, then which is equals to e raised to the power of 3x. Okay, all right. So at this point, we will now discover that, so this one now is now the same as this, then we can definitely replace it by this, right? So we'll now replace it, which is going to give us the z dx plus 2. This is z. Don't forget, so 2z, then which is equals to e raised to the power 3x. So from here, we can now say that p is equals to 2, and q is equals to e raised to the power of 3x. Then we'll look for integrating factor. So integrating factor is going to be e raised to the power of integral of p dx, which is going to be e raised to the power of integral of what is p? P is 2 and dx. Then if you integrate this, your if is going to be e raised to the power of 2x. So this is the integrating factor. So e raised to the power of 2x. Okay. Therefore, we now say that z multiplied by if, this is our formula now, is equal to integral of q multiplied by if dx, which will give us z multiplied by e raised to the power of 2x, which is equal to integral of q. What is q? q is e raised to the power of 3x. Integration factor is e raised to the power of 2x, then dx. So we have z multiplied by e raised to the power of 2x, which is equal to integral of e raised to the power of 5x dx. Okay, let's integrate. So if we integrate z, if you integrate this, e raised to the power of 2x, on integration is going to be e raised to the power of 5x over 5 plus c. 5x over 5 plus c. Okay. Then what is z? Don't forget that z is equals to y raised to the power of minus 3. So it's going to be y raised to the power of minus 3 e raised to the power of 2x, which is equal to e raised to the power of 5x over 5 plus c then, which is going to be 1 over y raised to the power of 3 multiplied by e raised to the power of 2x, which is equal to e raised to the power of 5x over 5 plus c. Okay, then we have e raised to the power of 2x over y raised to the power of 3, which is equal to e raised to the power of 5x over 5 plus c. Okay, and okay, let's try to remove this. So if we do that, we have okay, we can have e raised to the power of 2x over y raised to the power of 3, and which is going to be e raised to the power of 5x plus 5c over 5, right? Then we can have it that y raised to the power of 3 over e raised to the power of 2x is equals to 5 over e raised to the power of 5x plus 5c. Then by the time you cross multiply, we have that y raised to the power of 3 is equals to 5 e raised to the power of 2x over e raised to the power of 5x plus 5c. So that is our answer. All right, guys. So that is all for today. Make sure you like, share, comment, and don't forget to subscribe.